In my last video, I showed you how to add fractions with unlike denominators using models. In this video, we're going to convert mixed numbers into improper fractions using the strategy of adding fractions with unlike denominators. In class today, the first problem that we did was 2 and 3/4. 2 and 3/4. Now another way to say 2 and 3/4 is if I had two wholes, two of something plus 3/4 of it. So if I had two of something and 3/4, 2 plus 3/4. It's the same thing as saying 2 and 3/4. Now, when we talked about adding fractions with unlike denominators, the students recognized right away that there's only one fraction here. So I showed them a way that we can make this whole number into a fraction. I have 1, I have 2, and that equals 2. 1 plus 1 equals 2. On this first one, we're counting the whole thing. We're counting all of it. There we go. We're counting all of it. We're counting the whole thing. Now this 1 is broken up into one piece. The 1 is broken up into one piece, so that's our denominator. How many parts the whole is broken up into? It's broken up into one piece. And we're counting one part of that one piece. So our numerator is how much we're counting. We're counting one of it. It's broken up into one piece, and 1/1 is the same as 1. And the kids notice right away that anytime the numerator and the denominator are the same, it equals 1. So 1/1 is the same as 1. The same over here, 1/1. We have one piece that we're counting for our numerator, and it's broken up into one piece, 1/1. Now we have two fractions. We can add those two fractions together. 1/1 plus 1/1. Well, 1 plus 1 equals 2. 1/1 plus 1/1 is going to equal something that's the same as 2. One piece is still broken up into one piece, so our denominator stays the same. But we're counting 1, 2 of those. We're counting 2 of those. So our denominators are the same, so we can just add straight across. 1 plus 1 is 2. So the reason this is 2 is because one piece is broken up into 1, and we are counting 1, 2 of those 1. So 2/1 is the same as 2. I'm going to put that up here. 2 is the same as 2/1. 2/1 plus 3/4. Now we've changed it a little bit more. We've gone from 2 and 3/4 to 2 plus 3/4 to 2/1 plus 3/4. And that all means the same thing, 2 and 3/4. I'm going to erase a little bit of this stuff here. Now we have our 2. Now we need our 3/4. So I'm going to add our 3/4 into there. We're going to break this up into 4 parts. 1, 2, 3, 4, because that's what this says. We're going to shade in, so it's broken up into 4 parts. We're going to shade in 3 of those 4 parts. We're counting 3 of those 4 parts. 1, 2, 3 is what we're counting. So 1/4, 1/4, and 1/4. 1, 2, 3/4, 3/4, 1, 2. And 3/4. So let's go ahead and put these down here. 2/1, that's what this is, plus 3/4. That equals And we haven't done that yet because we can't add fractions when the denominators or the unit size are not the same. And on this one, the unit size is not the same. We have a 1 as a unit size here and a 4 as a unit size here. In the last video, I showed you how we could take two pieces of paper, stack them on top of each other, and fold them so that you can make equivalent fractions. And we're going to do something very similar with this, except we're just going to draw it in. We're not going to fold paper. This is broken up into 1, 2, 3, 4 parts. This one's going to be broken, so we need to break this one up into 4 parts, and this one up into 4 parts. We're going to make this one 4 times as many parts. Make this one 4 times more part. 1, 2, 3, 4. 1, 2, 3, 4. And now they're the same. That's broken up into 4. That's broken up into 4. And that's broken up into 4. Since we didn't change how much we are counting in here, all we did is changed how many parts it's broken up into. We made it 4 times more parts in each one. So we're going to take our fraction, which is 2 1/8, and we're going to multiply that by 4 4ths. We're going to make this 4 times as many parts, and this 4 times as many parts also. So 4 times 2 is 8. I'm going to do that in a different color. 8. And 1 times 4 is 4. And we just made an equivalent fraction for 2 1/8. Our new fraction is 8 4ths. So an equivalent fraction for 2 1/8 is 8 4ths, and now we have a new problem. And we can add straight across because the unit size is the same. But let's double check this 8 4ths to make sure that really is 2 1/8. So this is 2 1/8, both of those. 8 4ths, one of them is broken up into 4 parts, and we're counting 8 of those. 1, 2, 3, 4, 5, 6, 7, 8. 8 4ths. That is the same. And we still have our 3 4ths right here. So since the unit sizes are the same, we can add straight across to 8 plus 3 is 11. Our unit size of one of them is still 4. So let's double check our work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 4ths is the same as 2 3 4ths. When I was going to school, they showed me that you can multiply this 2 times 4 and add the 3, and that will get you your 11. And then the denominator just stays the same. It didn't make any sense to me why they did it that way, but that's what they told us to do, and that's what I did. What I'm teaching the kids is essentially the same thing, except instead of saying multiply 2 times 4 and add 3, I'm telling them to make equivalent fractions and add the fractions together. Our 2 times 4 is still the same. We still have our 2 times 4. Our 2 times 4 is right here. 2 times 4, that equals 8. Then I add this numerator of 3, and gets me a new numerator of 11. The denominator stays the same because 4 times 1 is 4, and the denominator will stay the same all the way across. The unit size is 4 on the whole thing. The unit size is 4 on this, so the unit size stays the same. And that's why that works, why you can do 2 times 4 plus 3. Actually, what you're doing is you're making it equivalent fractions in order to add fractions with unlike denominators. So that's how you make a mixed number, converted mixed number, into an improper fraction by using the strategy of adding fractions with unlike denominators.